Once again, our topic this morning is Downstream's release 2018. Version numbers are 14.0 for CAM350 and DFMStream and 6.0 for Blueprint PCB. The reason we're calling it Release 2018 is we've actually split this into a couple releases, so you will see a follow-on release that'll have some of the features that that didn't get into this release but are planned and they're important. So there will be a follow-on right after this release with some additional new features as well. So what is this release? It is a major release across both products, introducing some new technologies, new features, functionality. One of the biggest ones is the 3D technology for post-processing. So defining the Stackup. Now we're looking at the board in a 3D sense, right? We're looking at X and Y and Z. PCB modeling, want to show in greater detail either the entire PCB or a portion of the PCB. Panel visualization, being able to see a panel in 3D. This is something we feel is probably unique that we're doing, is when you create a panel over here on the CAM350 side, we can bring that into Adobe and look at it in 3D, or you can look at it in the CAM350 tool as well in the panel form. And also a facelift on our graphical user interface, or GUI. CAM350, as you know, has been around for a long time and probably really needed a facelift, and to bring it in line with our Blueprint product, we've gone to a ribbons methodology and a much more modern interface, not an interface that's been modified a few times, but basically had its roots in DOS of all things. That's how long it's been around. So why 3D? We want to actually visualize how the board's going to look once it's manufactured, but we want to see it before manufacturing. So we can do this various ways. Obviously, if you bring in intelligent data, you're going to get more information, including component information and height information if it's present. If you're working with Gerbers and NC over on the CAM350 side, we can still create a 3D model of the design, and I'll do that for you here. So we're not limited by the fact that all we have is Gerbers, NC, and maybe a net list. So if you look at it on the CAM side, you've got the Stackup information, which can be loaded up and modified and actually exported. We can look at the PCB in a 3D mode, again, whether it starts with intelligent data or whether it starts with a Gerber and NC. We can create a panel and visualize that panel, and then of course, with our Blueprint tool, we can enhance the documents that we release along with this. We can go beyond the whole idea of paper documents, which current PDF is. It's really just a version of paper documents, where it really is starting to become electronic paper with some of the things that you can do on the output of our Blueprint tool. So 2D, obviously you're limited to layers, basically turning on layers, maybe turning on some transparency, looking through them. 3D, of course, we can see the layers with the drill information. We can spread them apart. We can look inside. We can see buried and blind vias, how they only go through a certain number of layers. We even do some things like we'll change the solder mask to a reverse polarity so that you can actually see the surface mount inside of a solder mask clearance, as opposed to just having a dot for a solder mask clearance. So where you can use this, of course, is in your design reviews, just being able to look at the board in a much more intelligent format. You can use it as a reference in your fab shop. As an aside, I'm an old fabricator. That ability to zoom in the side of the board when troubleshooting would be really handy. I could think of, QA, electrical test, AOI, all those areas could benefit from being able to look at the design as a 3D model. And then, of course, creating your assembly documents themselves for use for assembly. that ability to see the components and see how their relationship is with each other, and then show that along with parts lists and details and some other things that we've enhanced to go along with the 3D representation. So as I said before, I'm not going to spend a lot of time in the PowerPoint here, but I just wanted to hit on the major highlights of CAM350, and then we'll go into some demo here. Obviously the 3D visualization, a new feature we're calling the Stackup visualizer, which is going to help us communicate back and forth between design and fabrication and creating the Stackup for this particular design. The new user interface with some enhancements, usability enhancement, being able to make use of multiple monitors, and some enhancements to how we've done analysis. These are all things that are in this release. And going on the topic of analysis, compare, DRC, DFF, all have been enhanced, giving you more options on how to use those. And this is through all levels of the tool. So whether it be a user who has our entry level bundles of the tools of CAM350 all the way to our highest DFMStream, and even our fabrication tool gets enhancements in these areas, including the 3D capabilities. And then we also have 3D PDF export in both tools, or the option for that, if you will. Being able to create a document that can be viewed and manipulated in Adobe, either on the shop floor, Q&A, as I mentioned before. Again, we're looking at the 3D visualization, the ability to create 3D documents, some enhancements to the user interface. You'll notice those immediately. Not huge changes, but some enhancements. The inclusion of the Stackup visualizer in Blueprint as well, and the ability to export 3D PDF. And here it becomes even more important as we can export documents in that 3D format as opposed to just a view of the PCB like we would on the CAM350 side. And then DFMStream, which, as you know, is the higher level bundles of CAM350 that have our Streams tool in them. And I should say that our Streams tool is available across all versions now. And one of the things you'll notice is if you were an old DRC or manual netlist compare user, you now get the Streams capability of doing those, which automates those processes and makes them much, much cleaner and easier to use. Obviously, we've improved the interface, goes along with the CAM350. We've really consolidated the dialogues. You'll see that when I do the demo. This universal error log, if you're familiar with the tool, then you know that depending on what type of analysis you did, you might get a different result viewer, and we've consolidated all of those. And then we've added a new feature that works off of the Design Analyzer, which was basically a quoting tool in the past, but now really allows us, the designer, to qualify vendors based on some parameters that you input and then the technology of the design. Visual Basic scripting across the CAM350 tools, that did not make it into the initial version, but that will be in the second release, 2018, so no longer limited to the macro language, which is still fully supported as far as being able to run your own macros, but we're not limited to that when we get the newer version out that does have the Visual Basic in it. It is a true 64-bit program as well as the licensing, so no longer a 32-bit program with the limitations on the amount of RAM that you can access. And hopefully you'll see, and we have seen, some significant speed gains by going to a 64-bit platform. There's a new common database between both CAM350 and Blueprint. When you worked in CAM350, you saved as a .cam, or if you're a really old user, a .pcb file. It really wasn't something you could work with on the Blueprint side. We have these two basic tools. What we've done is we've come up with a new database format, a DPD a downstream product database that you can save off of CAM350 and then open up that design in blueprint and work on it there. So starts to add some capabilities that will of course be added on as we continue with this release and other releases where we are using the same database, and it really adds a lot of flexibility to what we can do with our tools. You'll see some labels on the CAM350 side that are really going to help you as far as visualization, and when you're basically just looking at the data, you get a lot more information now. There's a component height table that you can modify if your CAD database for whatever reason doesn't have component height but you want to see it. You can modify those, and then of course some new visibility controls throughout both tools. New session here, and let's just talk about the new interface. So this is CAM350 version 14. You'll notice right away the differences in the graphical user interface, the GUI, a ribbons-based GUI, which goes in line with what we're seeing from most Windows-based tools these days, just kind of going through these menus just so you get a feel for what's in each one. Obviously, we've taken all the analysis capabilities and put them under one ribbon. Things you're trying to do to the design, like if you're trying to actually edit it, we've tried to add those to the design options and the home options, depending on what it is you're exactly trying to do to the design. Adding features, adding elements to the design. And then, of course, file I/O has even been cleaned up as well. And let's start with that. If you're used to the current version, when you went to either open or import, there were many different menus or views that you would get depending on what you were trying to import. We've tried to reduce those to just a couple different ones, an open option and an import option where you're looking at folders. So should be a lot cleaner as far as when you're bringing your data in. The auto import process, we're going to start with just some Gerbers here. We're going to tell it to look for the best matching template. This really hasn't changed that much. It's going to go out and look at the layer types, set your layer types for you, identify your layers. You can choose which layers to load, which layers not to load. Just as in previous versions, if you do have a net list in there, it'll go ahead and load that as well as any NC files that might be in there, and it'll go ahead and load those. But what's on the next screen is new. This is the Stackup visualizer. This is the one we'll see on import, especially the auto import, but you can also bring up the Stackup visualizer at any point when you're working in the tool. So those of you that are familiar with DFMStream and CAM350 know that when you did have partial holes, it was a little bit tedious to actually identify which layers they went through. You had to go into what we call layer sets, and those layer sets, you had to actually select each layer that a drill went through. One of the reasons for that was we never really forced you in the existing version to put the layers in any kind of order. As you can see here, we try to do that automatically. If you have to move them around, you can move them around. But when you're working with NC and Gerber, there's really nothing that tells us, specifically, what the layers are. So we do make some assumptions, and we may get them wrong. But once you do put these in the correct order, it's as simple now to work with the partial vias is a drag of your drills to show which layers those particular drills go through. And then, of course, when you're using your analysis, all of this is recognized so that, of course, if you're doing a missing pad check, it doesn't look on a layer that the partial via goes through. And you'll also notice that it sets the hole type here, and that works for blind, buried, and back drills. And what that does is by doing that, then we know to do the proper analysis over on the analysis side based on that hole type. More about the layer Stackup, I can take Gerbers and actually kind of add a dielectrics to them. And if I wanted to come out and change any of these, and this is important, is if I'm either a designer or a fabricator and I'm moving and I'm just trying to create a stack up, let's say an impedance stack up, and I do get some suggestions on you know, different layer thicknesses and so forth for my fabricator, I can come out here and make those changes, and then they're reflected in the stack up. And why that's important is that I can actually, and you won't see it in this menu, but in the Stackup visualizer itself, I can actually export this as an applet. And I say an applet because what it is it's a reduced version of the IPC 2581 specification, which just has the Stackup information. And then I can bring that into another tool. And in this case, I'm doing it in CAM350. I can bring it into Blueprint. There's even some CAD systems out there that do support this and to support the importing of that information directly into the CAD system. So now instead of having a stack up at the fabricator and a stack up in our CAD system, we can marry those two so that it's consistent if now we decide to go to a different a fabricator, for instance. We also have a materials table that we will create here, and you can build up a database of your, if you're a designer, of your fabricator's tools, so that you're not specifying some material that they don't use. Or if you're a fabricator, you can build up, you know, your own materials list and then choose the proper material as you're creating the stack up, and then have it updated in the stack up information. Okay, but once we're done with this, finish is all we need to do to move on to the visualization. And of course, if all you're doing is viewing the Gerbers, all I had to do was just hit auto import and hit finished, and I wouldn't have had to go through this step. So we've made it work both ways, you know, the real simplified method, but if we are moving on to some sort of analysis, obviously we want our layers labeled. So again, you'll see that the interface here is basically very similar to what we were used to, but there are some new things on here that you may not be aware of. First of all, one of the options is a worldview, and it's a useful worldview for a change. I think the one we had in the past might not have been as useful. This is typically what you'll see when you first get it, and as we move around in the tool, of course, the worldview shows us where that is. And we can turn on transparency, and we can show some of these new labels that I'm going to talk about a little more here in just a second. But one more interface thing before I do that is the other thing we can do is we've taken all the tables throughout the tool and we've tried to combine them in one location. So if you think about all these different things here, when you first load a design, you got messages, system messages. In the old navigation pane, you had things like decodes and nets and external nets and parts. Then we had a drill and mill tool table that probably most users never saw, but basically it listed in what purpose each drill was for. The layers table was a combination of this and a table that was kind of hidden inside the tool. So now you have that down here if you want to go in and do any modification to your layers, which layers there are, and so forth. Add layers, delete layers. And you can still do a lot of that out here, but we do give you that capability down here in this table as well. Things like pad stacks, and you'll see other things show up down here as we run analysis, if we've defined any areas for analysis. And then once we do run analysis, if we do have any errors, those will show down here. So these are some of the interface changes that you will see in this version. Okay. So let me do this, you know, just as before, I could turn on one layer and the others off with a double click, but the first thing you probably notice there is these numbers. Those are the decodes that are being used. Okay, so even at the Gerber and NC level, I'm getting these new labels. Obviously, I need nets and pin numbers to show those, but even at the Gerber and NC level, I'm seeing more information now. In the design. Of course, you can turn these on or off, and you get more information as you do use intelligent data. As a matter of fact, what I'm going to do now is actually bring up a different version of the same design, which is intelligent data. So we do have components on here. If I was to go down here to the parts, you would see all the parts with some height information. And all that information can be used in here. It actually can be modified to a certain degree. Some of these, you can change colors and put fills in and things like that. But we'll use that when we actually produce a 3D version of the tool. Let's do this. This is intelligent data, as I mentioned before. So let's turn on that same top layer. And just to show you the labels here, let's zoom in a little bit here. Obviously, I could change the colors, make this... So now you start to see some of the additional information that intelligent data provides us. So you've got our net names down in here as well. Okay. And then if we go over here to this, you can see we actually have our pin numbers showing here for this particular component. And again, you have choices over, which ones you want to see. I believe the pin numbers take priority over the D codes, so if you want to show the D codes, you can just turn pin numbers off, or if you don't want to see the D codes, you can turn those off, and you're just seeing the net names and the pin numbers. And you can see that hidden information. You can tell it to draw traces over flashes so that you can see that information. A lot of the right-click options that you had in the previous version are still available here. So one of the big features and functionality in this version is that whole idea of 3D. So if I just now move over into the 3D view, some things that I should mention to you. As you can see at the bottom, it's building the 3D model, but we've actually come up with a version of the color palette that is more reflective of what an actual board looks like. So while we're over here in the 3D mode, you can actually look at this as if it were a board, and as you can see, I can move around in here. If you have used 3D tools, you're probably familiar with some of these. You can see where we have inverted the solder mask there so that you're actually looking through to the pads. If I don't want to see the components, obviously I can turn them off or turn them back on again. We can do other things as you might be used to in other 3D tools. I can spread my layers apart here. If I don't want to see the dielectrics as a lump, I can zoom in, pull off layers, peel off layers, reapply layers, cut into the design, manipulate the design after I've cut into it. Again, spread those layers apart if there's a particular feature or layer or item I want to see, push into them. So all of these capabilities are available. And one more time, if you have intelligent data, you'll get the component information. If you have Gerbers and NC, you'll still be able to do this from that level, of course, without the components. More on the 3D capabilities as we go forward with the demo here, but I just want to give you an overview. And you can see there's many different options here as far as how we look at it. And again, I won't say that this is unique. I think this is a pretty common set of tools that are through all the 3D viewers, including the Adobe viewers out there. One thing that is kind of unique, of course, is turning on info tips and getting information about the actual design, what we're looking at in this 3D mode. So again, if I had to characterize, one of the biggest themes of this release is just more information, giving you more information with the same data without having you to go through and do additional steps. Now, one of the questions that does come up is that are we using step models for this? Not to render these components. We are using the component outlines and the height information to create these components here in the CAM350, and you'll also see that over in the blueprint world. While we can import a step model, it would be just of the board itself. It's not of the individual components and then placed into a board, but it is a rendering of the 3D based on, again, the component outlines and the height information. All right, let's go back into the 2D world here for just a second. I want to talk about one of the other things that's been changed in this version, and that is the analysis capabilities. We've had a checklist-based analysis for many years, probably about 10 years now. A lot of our users aren't even aware that we have it, and they may even have this capability, but they aren't. By checklist-based analysis, what I mean is that you have different types of analysis. We use the layer type methodology, and you can set the parameters for these analysis. We've tried to use, another thing that we've included is this default stream we call our checklist, that is really based on one of our major PCB manufacturers' capabilities, so that you're seeing real numbers when you are looking at these things, as opposed to just having to recreate it from scratch. It gives you a starting point to create your own checklist. And you can have as many of these as you want to. It can be based on technology, fabricator capabilities, whatever. But you'll see as you push into these now and you go to a particular one, like annular ring, for instance, and you go out here, if there are additional parameters that you can specify as well as what's in here with the numbers, those will show up here. This is completely floatable, dockable, bring it off onto another screen. The other thing we've done is we've split off the checklist from the results. So once I run this, my results show up down here in the Air Explorer, and I can go through those. And again, this is dockable as well. If you have multiple monitors, and most of us do now, and you can drag this information off onto other monitors, and again, as you're working, it kind of cleans up your interface so that you get the best view of the PCB possible. And as before, clicking on a particular error will take you to that error. But one of the nice things here in this version is that'll also take you to the 3D version of the error as well. So now we can view the results of an analysis in not only a 2D world, we can view it in a 3D world as well and see, exactly, and we'll put a little error marker on there for you so that you can see the particular error, and then, of course, you can move back and forth between the errors. Okay, so that's another new functionality, is being able to see the errors once you run analysis in both a 2D and a 3D mode. Okay, I'm going to answer a couple questions that have come in here before I go any further. Is the CAM file in the future still an ASCII-based text file as now? Yes, and there is an option to save as a CAM file. That has not changed. What has changed is over on the blueprint side, there is no longer the BPD option, the blueprint database. The only option is to save as the DPD. Now, of course, you can import BPD, the current file structure, but it will be saved from that point on in the DPD, which again can be used with both tools. Can we create a 3D model start from a 2D Gerber file? I think you might be asking if you can export it. I can export as a PDF. I can't create a step file from it, but I can create a 3D PDF from it. And I think I showed how you could just create the 3D, or maybe I didn't. So if I go back over here, this was our Gerber and NC that we loaded. If I just go into the 3D mode from the Gerber and NC, I basically get the same thing without the components. But again, I can come in here and spread these and peel them and so forth and see those. Can I sync the Stackup with my BOM table? What it creates is a separate table in the Stackup visualizer that you can export, and the import-export options are in the IPC 2581 format. So when you go into this materials table, you can export that. There is a CSV option as well, so perhaps that would be the methodology to update your BOM table with that information. I wanted to go back over here for one more thing, and then we'll need to To move on to some other things here, one of the things that we can do on this side with it doesn't really require intelligent data, but one of the things under analysis is the design analyzer. And what that design analyzer does is it's going to extract all the minimums, but what I can do is I can set up vendors, put their capabilities in here, and you can see I've got a couple of them here. Once I have those capabilities in there, I can just tell the tool to analyze first of all, it's going to extract the minimums, and then what it's going to do is look at these two vendors I have here and show me which of these vendors could build this particular design, okay? And if you see any differences, it doesn't look like I have any differences there, but it can even be down to the build time. Is, you know, maybe I need a 3-day turnaround, and maybe I need 100 boards. And it's going to let me know which ones of my vendors can do a 5 mil line and which can do a 3 mil line, and, you know, which could do a I don't know, 15 mil pitch surface mounts or something like that. But I can put these parameters in here, board size and so forth, and it is going to tell me which of my vendors can build this. So it helps me do that. Another feature I want to show you, and let's do this back over on the Gerber and NC. One of the enhancements we've made to the dialogues, because I think this is important, is that when you start looking through here at some of these things, let me just grab one here, like clear silkscreen. You know, we've tried to give you a better visualization of what's actually going on with this process. So if you're a fabricator, or even some of my designers clear their silkscreen, as soon as I enter a parameter, it actually is showing me what it's doing if I run this particular enhancement or cleanup tool. Okay, and another place we've done that is under the Analyze menu, Design Compare. So here's my original design, and let's go grab another design to compare it to. And obviously there's many uses for this functionality. I can hit Load, and what it's going to do is just basically load that second design in. All right, or I could have went straight to Run and just run it, and it would have loaded it and ran the comparison. But I want to do the load just again to show you this visualization enhancement that we're making throughout the tool. And again, this will get better as we, or not better, but there will be more of this as we go forward. So now I can actually see the two designs that I'm comparing, the local design and then this external design. And then when I'm ready to compare them, I can just go ahead and run them, and I can run them on everything, or if I have title blocks and stuff like that, I might just run inside the board outline and just see what the differences are inside of it. But basically, it goes through layer by layer, does the comparison, and again, just like before, the errors are split off from the actual analysis, so I don't really need this menu anymore. And I can come down here to my Error Explorer and click on a particular error and go to that particular error. And if I just select both of these, you can see I deleted a couple of traces here just to show you how we find the differences in the two. One last thing on the analysis side, and then we're going to move on to some of the more viewing options here, is not only do we still have this checklist-based analysis, and again, you know, there's about 100 different checks here that actually it's 120. If you are that user that had the old DRC, you'll now do it in streams, and there's some real nice enhancements there. For one thing, the old DRC didn't recognize the buried and blind VS. You'll be able to set up a checklist here, but you'll only have the analysis capabilities you had before, but you will be able to do it in this nice checklist format. So it should enhance your process, as well as you can do things like, you know, netlist compare. You can do that now in streams as opposed to the old utilities netlist extract and then analysis nets, compare external nets. Just basically one feature right in here. You can, you know, make any enhancements. There have been some enhancements to that particular feature as well. You'll be able to use those. Now, those aren't new enhancements, but those are enhancements that users of the older version did not have access to. One of those is if you have dummy nets or dollar mark none nets, which or no connect nets, you can now filter those out from the analysis, which you could not do in the old manual way. The other thing we've done is you now can just run a particular type of analysis without having to add it to the streams checklist. So if I just want to run copper spacing at 4 mils throughout the design, I can just say apply, and it's going to change all my values, or whichever ones I have checked, it's going to change them all to that particular value, or I can change an individual feature to that. And then you can run it, or you can save it to the stream to be used later. And you'll see annular ring, minimum feature, a lot of polygon analysis in here, and looking for slivers, that sort of thing. And also under the copper geometry, same sort of idea, and negative plane, specific checks to negative plane, solder mask, even some assembly checks, basically part outline to part outline, and some drill and mill checks, silk screen checks, paste checks even go out, and you can enter your stencil thickness, and it's going to look at the X and Y and make sure it matches the IPC recommended ratios. So again, you can do these interactively. The results will show down here in this Air Explorer, or you can do them in the checklist. And one more thing. One of the complaints we did have about the current design comparison was that it brought that second design in. Well, you can now just tell it to delete that imported design, and it will delete it after you do the comparison. All right, so let's move on. Another capability, and that's the 3D panel concept. Okay, so sorry, before I do that, I'm going to answer this question. Does the analyzer fetch the information out of the Gerber information and its pads or track parameters? What the design analyzer does is basically it goes in and let's just say spacing, for instance, trace-to-trace spacing. It goes through the design and looks for the smallest instance of trace-to-trace spacing, and that's the number that it puts in there. Same idea with trace to pad or annular ring or copper to hole barrel. It extracts that information from the graphics, if you will. It's not just pulling straight out of a Gerber file, and really that information isn't in a Gerber file. It has to go out and look at the graphics and find that information, and that's how it's extracting those minimums. All right, so I've got my board here, and I could go into 3D for that, but let's do this. Let's go over into panelization, and here's a panel that I've created fully in CAM350 with some tooling holes and coupons and things you might see on an assembly panel. Now, this could be a fabrication panel, and we've always had the capability to create either one, but and this could be either one because of what's on it: fiducials, tooling holes, step and repeat, mill tabs, web routes. So in this case, we're just doing this as if it were an assembly panel, but what I can do now is just come over into the 3D mode on this. And again, it does take a little bit to build the 3D model, so you'll see this little process indicator down here indicating that it is building the model. Okay, and then once it is, it'll show us that particular model over here. And again, we're using this PCB model mode so that it looks like a real board. Okay, so you can see some component height information there. One thing you might notice is if you have things like component information, if they're overhanging or if they're interfering with mill tabs or web routes, you can see that information in here. And again, all of the options available to you up here. So a 3D visualization of the panel with web routes, mill tabs, and so forth. All right. And then I could export a 3D PDF of this. And so here's one I created of our other board there. And again, we're in Adobe now, so I can manipulate this very similar to the controls I had over on the CAM350 side, but now we, of course, are in Adobe, and we can move these around and look and visualize this. Is one thing you might notice on this particular design is somebody made a mistake here and they put those LEDs right over top of the mill tabs. So there's a reason for doing the 3D visual inspection of the particular design as well. That's 3D PDF out of CAM350. And let's just talk about blueprint and the changes here on the blueprint side. You'll notice that the color palette the colors have been reduced, and I think this is a good thing. It kind of eases eye strain when you're working on a document creation tool and spending a lot of time in it. A reduced color palette was one of the things we did over here on the blueprint side. We've also made a few minor changes. You have your common elements palette is split off from the dimensioning palette, but still we have our fabrication palette and the things that go on a fab panel, an assembly panel, on a fab drawing, assembly drawing, and then we have our panel drawing palette as well. When we work on documents in Blueprint now, we set up a template like this. So everything from a fab drawing to here's that same assembly panel drawing, which we can create on the Blueprint side if we wanted to. A top and a bottom side view and a parts list, and we may put something else down here at the bottom. But this is all 2D world. And of course, if you're not familiar with Blueprint, to populate that template set, we basically import some data. We bring that data and it updates the drawings with that information, okay? And of course, we can move things around and view them however we want. And it pulls the Stackup information across if that's in there. And, here we've started our assembly panel drawing. And, one thing I should point out on the Blueprint side is I've already placed things like fiducials and tooling holes so that, I'm well on my way to create an assembly panel over here. Over here I have a top and a bottom side view, of course mirrored to show the bottom side, and then I have a parts list, and then we've also done things like hyperlink 2D world to a view of the actual PCB so you can see those particular items. Okay, so that's the way Blueprint works now, but with the addition of these tools that we've added here, we now give you some capabilities of adding 3D views, and we also give you the ability to manipulate the Stackup as well. So let's go back up into that Stackup visualizer. You can see this is what it looks like over here in the Blueprint side. The dielectrics came across. If there are no dielectrics, I can add them at this point. And then again, I can export this and either a CSV or a IPC 2581 format and bring that into another tool. So, of course, since this is intelligent data, you can see that those layer sets are already set up here. I do have a materials table over here on the Blueprint side as well that I can build up and add additional information to and export that to a database or import information from a database. I can also do a 3D view of this Stackup. So if I want to see this in kind of a 3D mode and see, how those layers look, I can create that over here in the Stackup visualizer. But probably the more important part is that I can come into my fab drawing now and actually add a 3D view, if you want to, of that particular item. Under the fabrication palette now, under the fabrication palette, you will see an option for a 3D Stackup. You can drag and drop that onto your drawing. Now, one thing you'll notice with this 3D Stackup, it reflects what I was doing over in the Stackup visualizer. So if I want to edit that 3D view, I can come over in here and do it and show it a different way or move it around, in that view. And then that gets updated into my 3D view. Okay, and you're going to notice this theme throughout, that the views are going to be editable, and you will update those. You can update those from the 3D model, and it'll update on your drawing. I could actually put down a 3D bare board if I wanted to on my fabrication drawing as well, so that the person on the other side that's opening this up can do that manipulation that we've shown over in the CAM350 side. I can actually do it from a document now, or I can actually do it on my PDF that I'm going to export from here. All right, my top side view here, just going to move it over a little bit, and I go to my assembly palette, and now I'm going to drop down a 3D view of that particular top side view. Okay, and then if I do want to do a manipulation of this, I just go into the edit mode, takes me over into here. You know, I can cut it, or however I want to manipulate this, and then of course when I do go back into my edit mode, it is reflected of what change I've made there. So if I want to just zoom into a part of the to the board, I can, you know, and I can have as many of these as I want to. I'm certainly not limited to the views. Let's go down here to the parts list. I want to show you another capability, and that is, as a matter of fact, actually before I do that, let's go back to the fab drawing. You see these fab notes here? Those are nice, but what if a lot of our military customers have got, you know, pages upon pages of fab notes. You know, what if you could drop down a fab note, since we are doing electronic data, it's scrollable. Okay, so there's a scrollable note block that I can do now, and I can do that throughout the tool, as opposed to just doing a flat, you know, here's everything, go across 5 pages if it takes that. You can actually have the ability to scroll through the note block. And there's another scrollable capability I'm going to show you in the parts list, but I just wanted to show you this on the fab drawing. So let's go down to the parts list. And again, I'm going to go to my assembly palette here, and I'm going to drag that 3D assembly over here again. We're just going to show another view of it. And I can decide how big I want it there and so forth. And then I'm going to put a scrollable parts list down here as well. So basically it's the same parts list that you see off to the left that it grabbed from the data, but now it's a scrollable parts list, but still hyperlinked. Okay. The other thing you can do is you can associate this. Is I can take this parts list and associate it to this 3D view if I wanted to. And what that does is once I create my 3D PDF, so I can choose which one I want to associate it to, but once I create my 3D PDF, that I can actually cross-probe back and forth between the parts list and the 3D view and select components and so forth in PDF. And I'm going to show you that in just one second, but I do want to show you one other feature in here, because we do get asked about STEP a lot. You know, we do have the capability of importing a STEP file, okay? But that's going to be kind of it's just one file, and it's not all the component heights. I think I mentioned this earlier and everything, but it's basically one view of the PCB we can bring in and drop down on a page. So, and the reason there is really each CAD system is doing it differently, so we really have no commonality that we can bring that information in. And, you know, the IPC 2581 spec is really looking at that. And it could be that in a future release of that, we will have that capability. But right now, everybody is just pretty much doing it their own way. I can import a step model. Once I do import it, just like everything else in Blueprint, when you import a view, it goes over into your imported content palette, and then of course you can take it and place it on a page. And you know, if you want to edit the view, it's just like we did before. We can come over here into our palette and see the particular view. Okay. If I were to look at my document set, okay, so now we've taken our standard templates and we've actually created a document set with much more information now. Lots of 3D information, Stackup information that we may or may not have, or we may need to modify. We can now work with over here on the document side, and scrollable items as opposed to flat parts lists and note blocks. All these things we can do to enhance the information that we're creating. And then, of course, the last step would be to create a PDF out of that. And in that PDF, we want to be able to manipulate just as we did over in the in the blueprint mode. So again, I can move things around over here. I can cross probe to them here, and it's going to go ahead and select a particular item. As a matter of fact, Adobe will build up a table of this as well. Not as clean as putting your own parts list, but there is that capability in Adobe that you can select a component out of that table and it will highlight it as well. But there's my 3D PCB view. An interesting thing that I discovered about Adobe is it's a 32-bit app. I think as we move forward as an industry more and more into PDF, we're going to see they're going to have to go to 64-bit, and just the memory capabilities, I think, is going to be a requirement of Adobe. So anyway, everything from that step model to the views of the PCB and the scrollable parts list, all of that I can view over here on the Adobe side. Okay. So just to recap on the blueprint side, the main changes are the Stackup visualizer, being able to communicate back and forth with Stackup information. And also there's some nice things in here like being able to show the layer names as you're working on them. That's in both tools. And being able to change the dielectrics. There's a properties dialog here, so I can show much more information, dielectric constant, loss tangent, all these things I can show in this table here and show the additional information as I'm building up this table. And then the second part, of course, is the 3D capabilities and being able to look at a design in both a 2D and a 3D space. Any questions on Blueprint or any additional questions on DFMStream and CAM350? In CAM350, if you have multiple PCBs on a panel, can you show that as a 3D PDF? Yeah, there would be no reason not to. Now, you should be aware that on the CAM350 side, if you do multiple, and I'm not sure if you're talking about multiple different PCBs or multiple, because I did show we had 4 up of the same PCB. But either one, if you're working with data over on the CAM350 side, yeah, you could create a 3D model of that and export it as PDF. Okay, you could show the mill tabs and the web routes and so forth. Hopefully that answered your question. I see the same question again about syncing the Stackup with the BOM list. Again, your options there would be to export as a CSV or a IPC 2581 and either bring it into your CAD tool and then have it update your BOM with that information, or bring it into your BOM tool, I guess, and update the information. Okay, hopefully this gave you a good overview of the changes in these tools. It should give you an idea of where we're going with the tools. As you can see, we have the common database. It really does give us some nice functionality that we can use for the future. Last question here, can you show multiple milled heights in a 3D PDF? We're not really supporting Z-axis milling in the tool yet, so that'll be something probably for the future, but right now I don't think CAM350 supports it at all. Well, I know it doesn't as far as a view of it. So the first step to doing that, of course, is forcing you to have a Stackup, something we've never done in CAM350 before. But now that we do have a Stackup, we can continue down that path, if you will, and provide capabilities like that. All right, thanks everybody for your time this morning. If you have additional questions, you can send those my way, rayf@downstreamtech.com. I am working on a full set of videos to go along with this new releases that will be out on our YouTube site. Most of you are probably familiar with that. There's probably 50, 60 videos out there right now. I try to keep them simple. I don't dress them up. I try to keep those where I can help people do a particular task and just get that information out to you rather quickly. And we will have a full set on these new tools.